Hi everyone, thank you for coming to this talk. I'm Phani Dathar, and thanks Chris for introducing me. How many of you have heard about GraphRAG before coming here? And even if you haven't, just when you hear about Neo4j, it's everywhere. Right now you're going to talk about, all we are talking about is GraphRAG because it is amazing and we are getting a lot of inquiries, understanding, like how can we make our RAG pipelines better? Is there a way for us to improve what we have been experimenting over the last couple of years when we first started experimenting with large language models and then building enterprise-ready generative AI applications? So my talk today is going to be about knowledge graphs, why you should care about graphs as a data structure, graph as a data structure, and how can you take advantage of this methodology called GraphRAG with Neo4j, all the tooling that's been made available using Neo4j. And also when you put all of these things together and the advancements, recent advancements that all of us have been hearing about, agentic AI, MCP, etc., how can you also put all these things together and take advantage of GraphRAG? When I talk about enterprise-ready generative AI applications, I just want to think about, or I just want you to think about what we did in early 2023, right? So when 2022, December, ChatGPT came out, 2 months later, when we were talking with our customers in an event organized by our company, they were coming, why do we even need any database? All I can do right now is take my application, interface with large language model, give all my data to large language models, and then that's it. I can expose my applications directly to the customers. I don't need anything else. All I have to do is serialize it, all the data, make it in the form of training data, and then give it to the large language model. And this is like a picture like this, of course, with some more improvements with large language models, like a simple question like, what's the impact of reciprocal tariffs? And an answer like this was right out of the box. Nobody has to do anything else, and it was so amazing. And soon, people were talking about hallucinations, how do we give our data to large language models, and regulatory industries like banks and pharmaceutical companies and life sciences companies are talking about, no, it's not something that we can use, right? That's when people started talking about RAG pipelines. A RAG pipeline is, again, when people started talking about, I can give my data and tell the large language models to keep answering questions only using my data. And then prompt engineering, guardrails, a lot of things happened over the last couple of years, right? But still, it wasn't really good until end of last year when almost everybody who started building GenAI applications started their data and then saying that, okay, structured data doesn't matter. All I have to do is just concatenate it, vectorize it, index it, and I'll get the answers, right? But that also was great compared to the previous RAG, but an answer like reciprocal tariffs was still not really pointing to what an enterprise application, enterprise user would look at. For example, a supply chain expert, when asking that question versus a generic journalist asking that question, is a different thing. And how do we get to a point where reciprocal tariffs are about helping, educating people about tariffs versus this particular order, which is on the line, is going to be affected by this reciprocal tariff because the cost is going to increase to my customer, which I need to communicate it right now. So to that point, we need accurate and relevant responses, as well as understanding who's asking the question, whether that person is, what's the role of that person, et cetera, et cetera. So when I talk about enterprise-ready GenAI applications, I'm not talking about the agentic approach or whether you're talking using different technology, but the domain expert or the actual application of actual application that's useful to an enterprise user. And this is where we need a data structure. And that's what my talk is about, right? And how do we get to the point from asking the LLM or just serializing the information, vectorizing the information versus getting the accurate to the point information for different persona inside an enterprise. And the key is mixed data, right? Because we have spent so many years, so many decades structuring the data, building different kinds of ETL pipelines with various kinds of transformation, logic, et cetera, to structure the data from all different kinds of data sources. And unstructured data has always been a problem, and then we have also worked with different NLP pipelines. But now it is not one or the other, it's actually combined. So any data structure that you take today, could be a table or a document, is not enough. And most of the data sources that we have, so all the machine learning models, improvements in the deep learning architectures that we saw, there was a few years everybody was talking about how amazing these deep learning models are, but later towards the end, again, there were discussions about if your data is not good, then your models are not going to do anything. So you always have to go back to making sure that your data was right, was correct, and there were no missing data points in it, and so on and so forth. Similarly, in this whole generative AI landscape, large language models are great in terms of making the connections, or generating natural language based on the questions, not understanding intent, but at least connecting the intent to the questions. But at the same time, you need to have the right data structure to store this kind of mixed data so that you can take advantage of this advancements in generative AI. And when you look at your data sources, even there were a few talks today talking about multimodal, and there were talks that there were panel discussions on how different regulatory industries have different data and different requirements, different security, et cetera, et cetera. So this is where most use cases today, if you really want to build out enterprise application, it's a collection of those data where you need linked structure, unstructured, and then even when you take your unstructured documents, there is some lexical structure in those documents. We should be able to capture that structure, and then and only then we should be able to, or we will be able to take advantage of all the advancements that we are seeing, whether you're deploying multiple agents, whether you are using the latest large language models or the APIs that you subscribe to, or the models that you're building and deploying, or open source data models or whatever, open source LLMs or whatever. So now the answer to that is what kind of data structure? And if you haven't heard about a graph as a data structure, so graphs are represented by nodes and relationships. Nodes are entities, and relationships are how these entities are connected to each other. And knowledge graph is where it's a graph that has emphasis on contextual understanding. And when you think about a knowledge graph or a graph as a data structure, then we can store vectors or latent representations of your textual data in the graph, as well as you can extract the entities, represent them as separate entities, and you can store structured data as well as semi-structured blobs of text and so on and so forth, and links and references to your data like audio files, video files, or even make connections or understand that here is an image that's embedded in a document, and this image is talking about so and so things. And that image is now connected to this image, which is also talking about so and so things. And this image follows that image, and so on and so forth. So make a logical connection between different parts of your data, and so on and so forth. So when you model data as a graph, especially using something like a property data graph model, then you start to see your mixed data come together and then form this data foundation that you should be able to leverage in all your advanced GenAI applications. So just to recap, what I was trying to say here is, when you truly want to build enterprise grade generative AI applications, it's not just using multiple agents, or it's not just using, or it's not one or the other. It's actually all these components have to work. Data, where you store data, what kinds of data, and then how are you orchestrating this whole retrieval and then summarization and then giving it back to the application, and then the large language models and all the advancements in that space that can take advantage of multimodal data and then make decipher that and then give you that information, right? So once we store that in the form of a graph using those building blocks like nodes and relationships, then you can come up with different shapes of data. So you can start with the structured data, which is at the top left side of the slide. You can say, here is an example, which is we are very fond of movie example as a company in Neo4j. If you look at all the documentation, you see movies, actors, and acted in, because it's easy to explain. It's easy to understand as a domain model. If you want to represent all the data in IMDb as using a domain model, then there are movies, there are people who are either directors or actors in the movie, and people acted in that movie, users rated that movie, critics rated that movie, and the movie has a name, movie has a description, etc., etc. So a simple graph like that can capture a lot of information in a very compact way. And then when you give this as the context to your generative AI application and start asking questions, hey, show me the movies that are Western, that have this, that belong, not just asking the right question, but maybe people riding on horses and shooting guns at each other. Then you should immediately see that, okay, Clint Eastwood will come up and his movies will come up, right? And then if you take documents, unstructured text, then you can represent chunks of the documents connected to the document so that when you're using your vector search, you don't end up with two chunks belong to the same document just because they are sharing a lot of similar context. Maybe it's because a side effect of your chunking strategy. So we can get rid of those unnecessary results and get better at connecting those things together. And we can even take your unstructured data, use the lexical structure in the documents, think about maintenance manuals, think about insurance policy documents. You can take advantage of the lexical structure and then come up with a graph like that. So the summary of this part of the talk is you have to look at a data structure that captures different parts, different aspects of your data so that you can make your overall application suitable for your whatever domain you're working. And when you think about knowledge graphs, like I said, knowledge graphs are the same graph data structures with emphasis on contextual understanding, and context is what you need to get relevant answers or accurate answers in your GenAI applications. And Neo4j is a database that helps us to build these knowledge graphs. And now once we have the graph in place, or the knowledge graph in place, then that becomes the data store in your RAG pipeline, and which you can call it as GraphRAG, where graph is a retrieval-augmented generation using knowledge graphs. And like I was mentioning, it improves GenAI by taking advantage of rich graph data structures and context that you can get from multiple types of data, multimodal data. What Neo4j is doing in this landscape is building out tooling and giving you access to different tooling to take advantage of this methodology called GraphRAG. And to do that, we have a Python package that you can take advantage of to get different kinds of retrieval patterns. What different kinds of retrieval patterns that you can use? You can use large language models to generate a query that works on these knowledge graphs. Or you can take a graph structure and then if you have looked at the paper from Microsoft, when they talk about GraphRAG, they were talking about, can I, instead of directly hitting the vector index with the question from the user, I want to pre-process the graph by generating higher and higher levels of summaries of questions so that I can look at the global data without losing context and then go down the tree to the local chunks in the text so that it can answer questions better. So that when the user is asking a question that doesn't find similar answer in a given chunk of text, but the context is buried in the global document, then those kinds of queries are answered much better. Again, it is not the power of large language model in understanding the context, but it's actually data being intelligent, or your data structure being intelligent, and then giving that context to the large language models so that you're helping the large language models to perform better. And those are called community summaries. And that's just an example. There are a few more retrieval patterns that you can use, and then create these different features that makes your GenAI applications truly enterprise grade. And when you think about, again, this is there is a blog post here. You can take a look at those. It's called GraphRAG Python package by my colleague Zach Blumenfeld. And that blog post talks about how do you take advantage of this versatile data structure and then use this in GraphRAG pipeline. You can start with your vector search. You can just, these vectors are stored as node properties in the graph, and they are indexed. So if you want to use it like a plain vector database, you can still do it as a starting point for your search applications, and then start from there, and then use the graph traversal to go and then get the information that you're looking for inside the graph, which are called query templates. They are deterministic in nature. Those are cipher. Those are written in query language. But the starting points for those traversal queries are obtained from the vector search, and that's like a hybrid retrieval pattern that you can take advantage of. And then there's always these large language models are getting better and better at generating cipher query language from natural language text. And that's one of the common retrieval patterns. And the other pattern that I talked about is community summaries, which is part of graph enrichment. There is also a collection of graph algorithms available through Graph Data Science Library, so that you can use to enrich your graph with more insights that also you can take advantage of in the retrieval patterns. So to summarize, what Neo4j is doing in this space is building the tooling for you to take advantage of this GraphRAG methodology, where knowledge graphs are used as data structures, and then take your feature set of your GenAI applications beyond your vector similarity search to take advantage of graph patterns, as well as improving search relevance and insights and improving the accuracy. Someone was asking about the evaluation metrics. Again, the evaluation metrics from different tools that are available are something that you can define and then evaluate on a graph. But I would like to look at it like completeness, accuracy, relevancy, and explainability, or some of those things that makes a lot more sense when you think about truly enterprise grade applications. Again, these are not formal definitions, but you'll find formal definitions or some kind of metrics in different kinds of evaluation tools that are coming up in this landscape. And once you put together, again, going back to some of the examples of GraphRAG, how a GraphRAG methodology is going to improve your overall GenAI applications. As an example, let's look at a legal contract review agent. If you just take all your legal contracts and then just vectorize them, index them, maybe use keyword search in them, then we can definitely answer questions like what contracts mention non-compete conditions. This was really impressive because before large language models and vector databases were in place, this was a hard question to answer if you did not do proper entity extraction from your unstructured text. And so this question itself is really impressive, but that's not enough. Now it formed the baseline. The baseline is, can you, in any of your application, can it answer this question? Then if you start extracting the entities out, then you can improve your questions, going from not just contracts that mention non-compete conditions, but find all the employee non-compete clauses with no expiry date, so that you can filter on the properties of those entities, and then you can do search at that, or you can surface those results. Again, this filtering, there are again things like pre-filtering and post-filtering, and there are some nuances in how you approach this filtering, but still it is much better, and it's actually good in expanding or a feature set of your GenAI applications. But once you start using knowledge graphs, then you can even think about what orgs incorporated in in states have perpetual employee non-compete clauses. What are the other similar legal agreements? Which legal documents talk about a specific domain, et cetera, et cetera. Similarly, on the retail side, here is an example. We have some code snippets on our website, and then we can share them with you if you're interested. Come and talk to us at the booth outside. Knowledge graph is to organize data. We can find similar items for content-based recommendations, similar to vector search. But if you want to do personalization beyond content-based recommendations, then you can start using graph patterns. And then you want to enrich those recommendations, hyper-personalization, then you can start using graph data science. And then finally, you can improve your overall fashion assistant. The next few minutes, so that's about GraphRAG. And again, I'm just scratching the surface. There are so many examples, so many interesting ways that you can improve your GenAI applications and go towards building truly enterprise-grade GenAI applications. And how can we take advantage of other advancements in the field? Agentic architecture. You can take these agents and then use these retrieval patterns that we talked about, use those agents, define those retrieval patterns, and then you can combine these. Like, you have the data sources on the left, you have processing, which is, again, you could use LLM, or if you have any other deterministic processing or any other transformation that you already have in place. Once we put that in Neo4j knowledge graph, then we can take advantage of these different retrieval patterns, and then you can combine those retrieval methods and then abstract them through different agents, and then use your LLM agent that parses the user intent, maps with the tool, and so on and so forth. So it's fairly straightforward. It's a level of abstraction on top of the retrieval patterns in GraphRAG. And here is a implementation called NeoConverse. Neo is from Neo4j. Converse is as if you're talking to your graph. NeoConverse, and it has the flow. It's implemented. It's available for you to go play with. And here's a blog post associated with that if you guys are interested to take a look at it. And one of the topics that I'm really I'm really excited about the application of knowledge graphs is improving the agentic memory. And we talked about this in 2023 about logging the conversations and making sure that the conversations with the chatbot or whatever the large language model are properly logged and understood. When a user asks a question, what prompt did the user use? What sources from the large language model were supplied to the large language model? What sources did the large language model use to answer that question? What was the follow-up question? How was it answered? Was there any overlap in the information? So that can be used in many different things. In case of regulatory industries, or in case of security, or in case of even making sure that it's consistent, so that you get confidence in deploying these applications in customer-facing applications outside, expose them to the customers. So this is part of this. All this is part of the long-term memory, not the short-term memory or session-based memory that you're seeing with large language models nowadays. It's not about increasing the context length. It's not about it's not about, hey, yeah, ChatGPT can do this, or Gemini can do this, but you really don't know how the damping factor applies to your conversations, and how the conversation, what's the attention given to the older and older conversations, depending on where you are. So this is much more explicit. When you use knowledge graphs, then you can have access information from previous conversations, and you can look at different kinds of memory. It's not just one memory anymore. It's not just logging conversations anymore. What about facts? How do you infuse facts as part of your RAG pipeline? How do you use episodic memory? Like, you experience something and then you want to use that episode in answering next questions. Can you refer to that episode and then start answering questions? So on and so forth. Procedural temporal is a great article by my colleague Alex, who actually talked about what should you think when you think about agentic memory. It's not just storing the previous conversation and giving you the answer. Enterprise applications it's not enough for enterprise applications. You need to think beyond that. And we also have the starting implementations of MCP that you can use right out of the box. And the get Neo4j schema uses, has a database agent that comes out of the box. Natural language questions are directly converted to cipher statements that are executed on Neo4j database, and you can integrate it with your applications. But read cipher, write cipher are also available as tools that you can expose to your MCP hosts. And then you can say, hey, here is my retrieval pattern, and then first run vector search, and then get the node IDs and then pass them as parameters to this cipher statement, go and then grab all the related neighborhoods. And one example is Amazon, which uses Neo4j for their security graph, and they presented at one of our events last year. Security engineers use Neo4j for their security analysis. Like if you have, if they say that, hey, what changed in this application? Does it require recertification? Look at that question, how deep it is. Like as a security engineer, if anyone in the audience, think about this question. If you want to, how do you prioritize recertification of these applications? And imagine a network like Amazon, how difficult it is. And having answers to those questions using a GenAI application is amazing. When you look at the answers, it's amazing. And that is possible by using a graph layer under the hood. And again, we have many statements, testimonials like that. The integrity and reliability of customer data. I think many of you had questions in the previous talk, or even discussing with us, how do you take care of security? How do you take care of these things, right? And finally, when you put all of this together, you'll start to see this architecture evolve. And this is not the only architecture. When you start looking at this GenAI landscape in a broader context, you start to see, oh, it's not, as I told in the beginning when I started this talk, applications are not directly interfacing with large language models and then you're done with it. That's not the case. It's actually there is a database component there. There is an orchestration layer. There is an agent to agent. There are multiple agents. There are large language models, and could be multiple large language models for different tasks, and then locally hosted models, etc. And then there are protocols like MCP, A2A. All of these things are going to evolve, and then this architecture, every component is going to become really interesting. And for data stores, look at knowledge graphs, and then you'll see how rich the data structure is. And with that, thank you. Thanks for listening to me.